Advanced Math Set 85B Clock Problems. Okay, so in the clock problems, the big hand that they refer to is the minute hand, and that hand moves one space per minute. The little hand that they refer to is the hour hand. The hour hand moves a lot more slowly. It moves 5 spaces every hour, so 5 spaces in 60 minutes, which reduces to be 1/12 of a space per minute. All of the clock problems are going to be set up in the same way. They're distance equals rate times times problems, where distance is your spaces. So R sub B is the rate of your big hand, and that's always going to be 1. And R sub L is the rate of the little hand, and that's always going to be 1/12. The spaces are always going to be S, and you add or subtract to the spaces, but you don't multiply the spaces. So let's do an example. The hands of a clock point in the same direction. In how many minutes will they point in opposite directions? So we'll draw a picture. Now the little hand's going to move a little bit, but then the big hand is going to have to move exactly 30 spaces more than what the big hand does. So using our equation, rate times time equals spaces, the little hand is moving S spaces, so the big hand is going to move S plus 30 spaces. So we'll set up our equation. Rate of the little times time of the little is space, is S. Rate of the big times time of the big is going to be S plus 30. Now we know the rate of the little is 1/12 and the rate of the big is 1, so we can plug that in, and we know that the times are going to be equal, and we'll just let those equal T. So 1/12 T equals S, and 1 T equals S plus 30. So from here, we're just going to substitute in. So 1/12 T goes in for S, so we get T equals 1/12 T plus 30. We'll subtract 1/12 T from T, and we get 11/12 T equals 30. Then multiply by 12/11, we get 360 over 11 for time, which is 32 8/11 minutes. Let's do the next problem. It's 3 o'clock. In how many minutes will the two hands of the clock be pointing in the same direction? So I like to draw a picture just to get an idea. We want to know when they're going to point in the same direction. You can kind of guess it's going to be somewhere around 3:20-ish, but we'll do the problem to figure it out. So the little hand is going to move S spaces, and the big hand is going to be exactly 15 spaces away, because they start off 15 apart and then they end up together. So however much the little hand moves plus 15 is going to give us how much the big hand is going to have to move. So we'll set up the equations. The rate of the little is 1/12, the rate of the big is 1, the time is going to be the same. So rate of the little times the time of the little is equal to S. The rate of the big times the time of the big is equal to S plus 15. We'll plug in the rates and the time. So we get 1/12 T equals S, and 1 T equals S plus 15. Now we'll just plug in, substitute in. T is equal to 1/12 T plus 15. Subtract 1/12 T from both sides. We get 11/12 T equals 15. Multiply both sides by 12/11, so we end up with 180 divided by 11. When you divide that out, you get T equals 16 4/11 minutes. And the estimate at the beginning that it was going to be around 3:20, so it's going to be about 3:16